Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. So in this video we are going to learn about toggle flip-flop. Okay, so toggle flip-flop, that is T flip-flop. So here T stands for toggle, right? If you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so what is toggling? So generally toggling, right, toggling means changing the output from 0 to 1 or from 1 to 0. Okay, so if the previous output is 0, you are going to change it to 1, or if the previous output is 1, you are going to change it to 0. So this process of changing 1 to 0 or from 0 to 1 is called as toggling. Okay, so that is called as toggling, right? So the first point which you have to remember for T flip-flop is T flip-flop, so is not a new flip-flop. T flip-flop is again derived. T flip-flop is derived from JK flip-flop. Okay, so T flip-flop is derived from JK flip-flop by connecting J and K inputs together. By connecting J and K inputs together. That's all. So if you remember this point, then everything about T flip-flop is you can easily derive at the time of examination only. Just remember this point, just remember this important point. So J and K, so I'm taking a JK flip-flop, so with a negative clock pulse, right? So J and K I'm taking Q and Q bar. Now this is your JK flip-flop. Now we want to convert this JK flip-flop into T flip-flop. So by connecting J and K inputs together, so I'm shorting the J and K inputs. I'm giving the input called T. That's all. So this flip-flop is a T flip-flop. So T flip-flop, it is equivalent to, so this circuit is equivalent to T flip-flop. So T flip-flop will be like this. It will have a negative clock pulse, T here, Q bar. So this circuit will act as T flip-flop. Okay, so if you want to write the truth table, so how you are going to write the truth table? T and Q, because only one input is there. So if you give T is equal to 0, when T is equal to 0, so what will happen when T is equal to 0? J is equal to 0 and K is equal to 0. So we have seen from JK flip-flop that when J is equal to 0 and K is equal to 0, then Qn plus 1 is equal to Qn bar. So Qn plus 1 is equal to Qn, right? So when T is equal to 1, J is equal to 1 and K is also equal to 1. So in this case Qn plus 1 is equal to Qn bar. So when T is equal to 0, Qn plus 1 is equal to Qn. When T is equal to 1, Qn plus 1 is equal to Qn bar. When T is equal to 0, Qn plus 1 is equal to Qn. When T is equal to 1, Qn plus 1 is equal to Qn bar. That's all. This is the truth table. If you want to write the excitation table, so if you want to write a excitation table, okay, so if you want to write the excitation table, Qn plus 1, so based on Qn and Qn plus 1 we have to write the values of T. So 0 0 0 1 1 0 and 1 1. Okay, so if you see here, right, so 0 to 0, so Qn plus 1 is equal to Qn. When Qn plus 1 is equal to Qn, then what is the value of T? So when T is equal to 0 only, Qn plus 1 is equal to Qn. Now in this case, if you observe here, so Qn plus 1 is equal to Qn bar. So when will be the Qn plus 1 is equal to Qn bar? So when T is equal to 1. So here T is equal to 1. Similarly here also Qn plus 1 is equal to Qn bar, so it is 1. This happens when T is equal to 1, so you have to write 1 here. and Qn plus 1 is equal to Qn. So this happens when t is equal to 0, so you have to write 0 here. That's all. So this is how we can solve the excitation table. So just by remembering this single point, you can derive the T flip-flop, either truth table or excitation table, anything. Okay, so the last thing is characteristic equation. So what is the characteristic equation of T flip-flop? So characteristic equation is always done with respect to Qn plus 1, right? So here T Qn or the inputs, Qn plus 1 is the output. So if you want to derive, so 0 0 0 1 1 0 1 1, right? So when T is equal to 0, Qn plus 1 is equal to Qn, right? So you'll get 0 1 like this. For the first two cases, T is equal to 0, so you'll get Qn plus 1 which is equal to Qn. So I'm writing the same values here, right? For the next two cases, if you see, so this will be 1. When T is equal to 1, Qn plus 1 is equal to Qn bar. So 0 is changed to 1 Qn bar, and 1 is changed to 0. Okay, so if you want, you can draw a two variable K map like this, right? So T Qn 0 1 0 1. So where will be the min terms available? So at 0 1 and 1 0. So these are the variables, so no mapping is possible. So what will be Qn plus 1? Qn plus 1 is equal to T bar Qn plus T Qn bar. So A bar B, so this is like A bar B plus AB bar, which is XOR gate. So it is T XOR with Qn. So Qn plus 1 is T XOR with Qn. This is the characteristic equation of T flip-flop. Okay, so this is about T flip-flop. You just have to remember only the single point and JK flip-flop concept. If you are okay, then it is very easy, right?